Hello, year 6. Welcome to unit number 6, the digital revolution. Today we have the section of learning from analog to digital, something that is quite easy, I guess, for you because you know about technology a lot, and all these devices we are going to talk about, you use them every day at home, okay? So what's analog? What is digital? Here we've got two examples that are very easy to see what's the difference between them, okay? So here we've got this clock. This one it's analog and this one is digital, okay? Can you tell what's the difference between them? Tell me at least three differences that you can see. Okay, let's learn a little bit more about analog devices, right?
Unit 6, page 86, From Analog to Digital.
We can find both analog and digital devices around us today. But can you tell the difference between them? Analog devices. Analog devices provide a continuous transmission of information. Traditional clocks with rotating hands are analog devices. The continuous movement of the clock's hands is similar or analogous to the way that time passes. Old-fashioned thermometers that have liquid inside them are also analog devices. Changes in temperature are represented by the continuous rising and falling of the liquid. Other devices that depend on analog technology include scales with weights and moving parts, cameras that use photosensitive film, music systems that play vinyl records.
If there are some words that you don't understand, please, my piece of advice is to go to the dictionary and find the words I told you before. Word reference and Cambridge Dictionary are very good. Some examples that of the devices, analog devices, so using analog technology. You can see here this system to play music with vinyl records. You might have them at home. Maybe your parents have some of them, still have them. Also the cameras used this photosensitive film. I have them and I've used them. And it brings me a lot of memories here. Estos son los negativos, los que llamaban los negativos, and we had to be careful and put it carefully in the cameras. This is a scale to weigh food and to see, you see moving the hand here to see what's the weight of the object that we put here on top of here. You have seen me using them in the school. And this is a thermometer, a traditional one. Okay, good. Let's move on and find out about digital devices.
Unit 6, page 86, Digital Devices.
Digital devices use a two-digit or binary code of zeros and ones to represent information. For example, the digits 0101 represent the number 5 in binary code. Digital devices use binary code to represent values such as time, temperature, weight, sound, light, or colors. Nowadays, we use a variety of digital devices, including clocks, thermometers, cameras, and music players. Some everyday devices that use digital technology include home computers and laptops, mobile phones, tablets, and e-readers, wireless speakers and headphones.
I hope you find it interesting, and here you've got some examples that I'm not going to stop now explaining to you. Why? Because you know even more than I know about them. Okay? Now, analog and digital signals, what's the main difference here? The signals that are transmitted in an analog device or in a digital device is very different. It can be seen easily when we record them. I don't know if you have used tapes to listen to music or to record music or vinyl, but I think it's easier for you to have experienced the tapes. In the tape, when you started recording, then if you wanted to go to the song number 5, the track 5, you couldn't just play and go, okay, I want to go track 5. No, you had to rewind or to go faster and guess more or less where you had to stop, okay, or play stop till you find it. Or in the vinyl, you had to listen to it from the beginning till the end. Okay, it was very difficult to go to a specific track or specific moment. That's different with a digital diagram, with the MP3 songs, or even with the CDs. We can play the CD in a CD player and go to different tracks. Okay, why? Because they are recorded one by one, and then we can go here, and then we can go to track number 9 or track number 5 if we want. Okay, but with the other device, the analog, it was impossible. You had to just play it and maybe stop. Okay, I think that here, maybe here. Okay, but it's not the same. Okay, let's read this and listen to this paragraph, but more or less is what I've explained to you. If we were in class, I could show you a tape and you could understand me better, but this is a fantastic way for you to ask your parents how did they listen to music, and if they have some examples. If they have, please let me know what they told you, okay, because it's very interesting. But they can explain to you el cassette. You can ask them for a cassette when they wanted to listen to, I don't know, the song number 5, okay, of their recording. What did they have to do? They are going to explain to you, okay, and then you can understand my explanation. Good.
Unit 6, page 87. Analog and digital signals.
Analog signals are transmitted in a continuous flow. A vinyl record is an analog recording in which the sound is stored continuously. In contrast, digital recordings like MP3 songs are discontinuous pieces of binary code. These separate pieces can be stored and transmitted as packets of information and reassembled later.
And the next thing we are going to focus on is in the digital sampling. Analog signals can be converted to digital signals by breaking them down into many pieces of or samples, as the packings that we were saying or we read in the previous text. Okay, let's read this. It's very interesting. I've done it. I've converted some of my VHS videos when I was a child. I have converted them to the digital mode, and this way I can have them in a memory stick and play them, and I don't need to have the tape to play it, which was difficult to have these days. So it can be done, yeah.
Unit 6, page 87. Digital sampling.
Analog signals can be converted to digital signals by breaking them down into many pieces or samples. These samples are stored and transmitted as binary code. Later, the samples can be reassembled in the correct order and reproduced as a continuous signal. The graph shows the analog signal as a continuous red line and the digital sample in blue blocks.
Good. So I hope you understand it. It's quite easy, and it's just to see the difference between analog and digital. And now what I suggest you to do for homework are the exercises number 1. What is the main difference between an analog and digital watch? You can write the answer in a piece of paper. When you have finished, keep it for next day, next Tuesday, where these exercises will be corrected. Okay? Then you have to do exercise number 3, in which different formats, analog or digital, can music be stored? Think carefully that question, okay? Then exercise number 4, listen to the statements and write true or false in your notebook. This is a listening, so you have to listen carefully and then write down the answers in your notebook. It's taking its time. Okay, here we are.
A. Digital thermometers use liquid to show temperature. B. Analog scales have moving parts and weights. C. Computers use binary code to store and transmit data. D. Digital signals use a continuous flow of information. E. Analog signals are stored as tiny packets of code.
Finally, exercise number 5. What is a pixel? How do digital cameras use pixels to form images? You have to find this information on the internet, okay? Go to Kiddle. I think it's the best way to find information, and write down your answers, please. I hope you liked the lesson of today. Work hard, study, and see you next day in Natural Science lesson. Bye bye.